Hello every students. Today the topic is chapter 12, reacting mass, and then first part is what is a mole. So what's a mole concept? Before that, I want you to understand what is a dozen. So a dozen actually is a counting units, which is represent 12. So 1,000 eggs represent 12 eggs, I suppose everyone will know, right? But in chemistry, there are the particles like atoms, molecules, even ions that are very small and also very difficult to count it. Like one drop of water, actually it contains many water molecules. Like 1 gram of water actually contain 3 point something times 10 to power 22 water molecules. So if you use a dozen to count it, they're very difficult. Therefore, the chemists use their own counting units that we call mole. Mole, we can use the symbol represent mole, MOL. This is a symbol of mole. So actually 1,000 eggs represent 12 eggs. Then 1 mole eggs, just like 1 mol, 1 mole represents 6.02 times 10 to 23 eggs. And this number actually is as a meaning, actually it is a Avogadro constant. This constant is the value of 6.02 times 10 to power 23 mole negative 1. What means mole negative 1? Mole negative 1 means that 1 mole of substance, that means that it has the amount is 6.02 times 10 to power 23, right? And this number, Avogadro constant, you have to memorize. When I study in secondary school, how can I memorize this number? Firstly, I will memorize the power first. The power is 23. You know, one of the very famous basketball player, he is Michael Jordan, and his basketball jersey number is 23. So that Michael Jordan, so I like him so that I know his number. So for memorizing this Avogadro constant, for this power to 23 is easy for me to memorize it. So that you just need to memorize 6.02, and then you know the constant number is 6.02 times 10 to power 23. So this Avogadro constant later on we'll use it for calculation. So and then after that, Avogadro constant also applies to atoms, for counting atoms, molecules, ions, and even electrons. So for example, one sodium metal or one sodium, actually it represents 1 sodium atom. But if 1 mole sodium, that means that it contains 6.02 times 10 to power 23 sodium atoms, right? And now for the compound sodium chloride. For 1 sodium chloride, actually it contains 1 sodium ion and 1 chloride ion. As a sodium chloride is ionic compound, okay, so that it consists of 1 cation and 1 anion. So if 1 mole sodium chloride, then actually it contains 1 mole sodium ion and 1 mole chloride ion. And 1 mole, we just tell you it actually is represent a number, right? Constant number. A number. So what's the number? The number is 6.002 times 10 to power 23. Right? So here. And 1 mole chloride ion still contains 6.02 times 10 to power 23. So chloride ion. So I hope you understand this mole concept right now. Okay, now see the second part is converting between moles and number of particles. So for example, you can see the right hand side. 1 dozen eggs, as I said before, actually is equal to 12 eggs, right? Then how about 2 dozens? 2 dozen means 24, right? How to get the 24? Just use 2 times 12, right? That equal to 24. Now we go back to molecules. If 1 mole X actually is equal to 6.02 times 10 to power 23 X, right? Then how about 2 mole X? So how many X then? Is use 2 times Avogadro constant, 6.02 times 10 to power 23, right? And then how about 0.1 mole? 0.1 mole, just use the similar methods. 0.1 times 6.02 times 10 to power 23. Okay, so I understand the conversion between the moles and the number of particles. Okay, now let's see further. 0.1 mole of water molecules contain 0.1 times 6.02 times 10 to power 23 molecules, right? This makes sense. But now, if I don't ask you molecules, but I ask you atoms, how many atoms in 0.1 mole of water? How many atoms? So that total number of atoms in 0.1 mole of water molecules, it should be 3 times 0.1 times 6.02 times 10 to the power 23 atoms. Okay, why we use 3 times? Because we know that each water molecule, water molecule actually is H2O, right? And it contains 3 atoms. So 2 hydrogen atoms and 1 oxygen atoms. So if we want to count the total number of atoms, then we have to use 3 times the number of total number of water molecule, right? So 3 times 0.1 times 6.02 times 10 to the power 23. Okay, so here is also a equation to represent the relationship. This one, I mean. So you can see total number of particles in a substance equal to number of moles of a substance times Avogadro constant. So for example, total number of particles in a substance. For example, we just focus on the first sentence, 0.1 mole of water molecule. So the total number of particles in substance, that means that 0.1 mole of water molecule. Then how many water molecules in it? Then we just use this equation. So total number of moles. So number of moles of the substance actually is equal to 0.1 mole. 0.1 mole. And then Avogadro constant is times 6.02 times 10 to power 23. Then we can get the answers. And this equation is also interconverted. Like for example, the right hand side, total number of eggs, for example 36, and actually is equal to the dozen number times 12. That means that should be 3 dozens and times 12, then equal to 36. And this equation can be also converted into, if we want to ask the number of dozens, that means that the dozen number equal to total number of eggs divided by 12. Then 36 divided by 12 is equal to 3. So the dozen number is 3. So it means that this equation can be also interconverted. Now we go back to the real equation. And you can see that the total number of particles in a substance equal to the number of moles in a substance times Avogadro constant. means that times 6.02 times 10 to power 23. And then if you want to ask the counting unit, means that we want to ask the number of moles, then we just simply use the total number of particles and then divided by the Avogadro constant 6.02 times 10 to power 23. Then we can get the counting unit, the total number of moles. We got it. Okay, this interconversion concept is very important for later on, so bear in mind. Okay, we have just learned the interconversion of the equation. So now just a reminder. So let's see the right hand side. If you want to calculate the dozen number of eggs, and then we just use the equation, the total number of eggs divided by 12, because we know that 1 dozen is equal to 12. So for example, total number of eggs is equal to 36, then the dozen number should be equal to 3, right? So the equation is similar. So this equation we have learned before. Now let's do some examples. Let's see the example. A sample contains 5.6 moles of sodium carbonate. And now ask how many formula units. What means formula unit? Formula unit means that how many sodium carbonate particle you can say. So you can say sodium carbonate particle. How many? Total number. Okay. And then the number of formula unit, actually you just use the previous equation, or you can use the equation above. You just do some conversion, and then you can find the total number of particles of the units in sodium carbonate. Then we just use total number of moles times the Avogadro constant, and then total number of moles is given. That is a 5.6 mole, right? So 5.6 moles, and then times Avogadro constants. Then you can find the final answers. So you can see the Avogadro constant, the unit is mole -1, and then can cancel with the mole. So the final answer is 3.37 times 10 to power 24. And then the second part, asking you about the total number of ions in sodium carbonate. We know that one sodium carbonate, that means 1 Na2CO3, actually it contains 2 sodium ions and 1 carbonate ion. That means that totally there are 3 ions. So you can see here, 1 unit of Na2CO3 contains 2 sodium ions and 1 carbonate ion. That means that when we do the calculation, we just use 3 times the total number of formula unit. Then we can find answers. Or you can use 3 times 5.6 mole times 6.02 times 10 to power 23 mole -1. Still can find the final answers, because 5.6 mole and then times 6.02 times 10 to power -3, that means the total number of particles in sodium carbonate. Okay, but now we don't ask the sodium carbonate particles, but we ask the ions in sodium carbonate. Then we know that there are 3 ions in sodium carbonate. That means that we use 3 times. Okay, we use 3 times the total numbers, so that the final answer still equal to 1.01 times 10 to power 25. Still can get the answers. Okay, this is an example. I hope you understand. And then following the some practice, then you can also do at home. That's inside your textbook. You can also check the answer after that to see whether you understand or not. And after this, I will give you some homework. Then you have to finish by next week. Thank you.